tonight's January novice meeting is going to be about our winter sky, which is really one of my favorite times of year. There's plenty of beautiful, interesting, and very accessible objects that you can go out and view, as well as a few challenging ones. The topics that we'll be talking about tonight will be as follows. We'll talk about preparing for the elements. I know Houston is 95% of the time is very hot, but it looks like we're going to have a cool snap coming up, so this information will be timely. Then we'll jump into navigating the night sky and go through some quick refresher items that will help you in your quest to go find and view these objects. We'll talk about Orion as a signpost, which will be a really key concept for you to learn in order to find your way around the night sky. And then we'll go through the various winter sky objects that are out there for viewing. And again, there's just some wonderful objects out there that are available and quite accessible. So winter is here for about 2 weeks. I don't know if that's true, but we are going to have a cold snap next week. I'm going to be out of town starting January 8th, which is the coolest night. My wife's not joining me on this particular trip, so she gets to stay home and run the freeze precautions here at the house. But it is going to be pretty cold. I've lived here about a little over 40 years, and while it's normally hot and humid down here, we can get cold weather, and it can be dangerously cold. So what you want to try to do as you're going out and you're doing your astronomical viewing during the nights out here, and the winter nights are really great because you got such clear, crisp skies. You want to try to overdress a little bit by about 20 degrees or so. So if it's going to be 40 degrees outside, try to prepare for 20 degrees. And dress in layers so that if the conditions are such that you're not as cold as you thought you were going to be, you can peel off those layers. Here is some recommended clothing for these winter nights out at the either the dark side or out in your driveway, the local park. You'll want to have a beanie or a stocking cap. Certainly want to have a winter coat. I still have mine from my youth when I lived in Washington State, and it still fits, so that's nice. You want to have thermal or moisture-proof pants that you can put on over jeans or your regular pants. Gloves, got to have gloves. Thermal socks. If you hike and you have hiking socks, that'll suffice. There are items that you can buy that are little pellets or packs that you can bust open, and they'll provide either hand or foot warmers for you. You can put them in your pockets or put them in your boots. You want to have boots. Boots will keep you warmer than typically a pair of tennis shoes would. And if you're out at the dark side, having a substantial boot with some protection around the ankle is advisable because there are some uneven turf out there as you're making your way through the dark side, and in the dark as well. Long underwear is always a good idea, both top and bottom if you have them. And then it's always a great idea just to take a blanket with you that you can kind of put on and off. As you're out there stargazing, you're not moving around a whole heck of a lot, so you tend to get a little bit colder than you typically would if you were out taking a walk or doing something of that nature. So here's my kit, and I'll just kind of walk through it real briefly. Again, here's the stocking cap. Here is that warm winter jacket from my youth, down-filled jacket. I also have here some bib overall ski pants that I had from my college days when I actually used to ski, and now they're great because I can put them on over my jeans, and they can go way up underneath the jacket and provide warmth, even in the chest area. Of course, you got to have your gloves, some substantial socks, and then this is one of those hand foot warmer packs I was talking about. Now here's the blanket that I have that I really love. It is a blanket, but it actually fits like a poncho. So up here you've got a hood, and then you can't really see it here, but along the side you have some straps that you can put your hands through, and you can put it on and off just like a poncho. And it's nice because it just makes it easier and more stable, keeping it on your body. So again, but any blanket will do, a quilt, anything that will provide some warmth while you're sitting out there under the stars. I did invest here a while back in some electric socks. These are my electric socks. There is a small battery that fits right here and is tucked into a pouch right here. Here are the on-off buttons. You've got a couple of different temperature settings. Blue is kind of the medium, and then red is the high. These batteries will last about 5 hours or so. So if you're out there for a long length of time, like when I go out to do astrophotography, I'm out there all night. The batteries will run out, but it'll at least keep your feet warm for a pretty good period of time. And if you're out just doing some star hopping, excuse me, star hopping in your driveway, when the batteries are out, it's probably time to come in anyway. So, electric socks, think about that. So, that'll give you some ideas on how to prepare. Let's talk a little bit about the night sky and just go through a quick refresher on that. So, if you're brand new to astronomy or relatively new to astronomy, the one concept you really want to get under your belt quickly is the idea of a celestial sphere. So, think about the Earth and then think about this imaginary sphere that sits out and around Earth. This is where all the stars and all of the planets and all of the various objects, galaxies, etc., they will sit on this sphere at some location. For everything except the sun and the planets, their location on the sphere will be denoted by coordinates that are called right ascension, which is analogous to longitude here on Earth, and declination, which is analogous to latitude. So if you know the right ascension and declination of coordinates of any object, star, etc., you can go to any star atlas or fold out map of the night sky, and you should be able to find the location of that particular object. The north and south celestial poles are the same as the north and south pole on Earth. The celestial equator is parallel to the equator on Earth, and that's kind of the simplified model for beginning to find your way around the night sky. Now, for the sun and the planets, they are on the celestial sphere, but they actually travel in a path that you see denoted here called the ecliptic. An ecliptic is a circle, imaginary circle that runs up and around on the celestial sphere, but is at a tilt to Earth. And this is where you're going to find the sun and the planets as they make their way across the night sky. You may notice if you've been outside lately, when you look to the east, you'll see Mars is very bright and apparent. And if you follow the path of Mars, it looks like one of the brighter stars in the sky, and it's got a very distinct reddish color. But if you follow Mars through its pathway during the sky, it's actually going to follow this ecliptic, this path right here, which will be different than, say, the star Rigel, which is one of the stars in Orion. So, very important distinction to make there. Also, to be aware of the apparent motion of the stars and various objects in the night sky are going to be dependent on your latitude. So if you look at this diagram here on the left, you'll see this individual is standing at the top of the Earth on the North Pole. He has Polaris right over the top of his head, and objects will appear throughout the course of the evening to circle over his head. So the Big Dipper, Orion's Belt, they will all circle around him and never really go down below the horizon. Okay. The only thing that will make these objects disappear is when daylight occurs. Of course, this time of year it's probably dark 24 hours a day at the North Pole, so you'll be able to see these all night. Now, as you move farther south, in this case, what you're going to find is Polaris will actually change position. And in our case, we are at a latitude of about 29 degrees here in Houston, 29 degrees north, and Polaris will appear to be 29 degrees above the horizon. So if you know what latitude you're at, you'll know what altitude above, or what, how many degrees above the horizon you'll need to look in order to find Polaris. And then you'll notice that stars like the Big Dipper or Orion or Cassiopeia, they will appear to rise out of the east and come up overhead and then set in the west and go down below the horizon. So as you're out there, make note of that, and that is a great way to, again, use the celestial sphere to kind of understand, where these objects are moving and why they're moving. Here is another perspective. So the models that we have looked at so far are kind of Earth or geocentric or Earth centric. It's kind of, what's happening around us. This kind of flips the script and really puts the Earth out as one of many objects out in our galactic plane. And so here is the orbit of the Earth around the sun. And at each point here, here, and here, those represent the point at which the Earth is at during, in our case, tonight, where we're at in the winter sky. So this is actually was going to be on December 20th, which is the winter solstice. But here is where Earth is in our rotation around the sun. And as we look out into the night sky, we're actually looking out through the galactic plane, but we're looking out away from the center of the Milky Way. When we get into springtime, we'll be up here and we'll be looking out beyond the Milky Way. And this is part of the year is termed galaxy season, because not only are we looking through the thinnest part of the galactic plane, but we're also looking out into a very rich area of the sky that has a lot of galaxies. In the summer, we will be down here and actually looking back towards the center of the galaxy. So that's when you get these really beautiful Milky Way photos that show the bright core of the Milky Way. And then over here in the autumn, again, we'll be looking back down out away from the galaxy. So again, this is just another way to look at the celestial sphere and where we are at in the scheme of things. One resource that I highly recommend that everybody utilizes is Sky Maps. If you go to skymaps.com, for free, you can download this picture of the night sky. And this is a great place to start. So if you take a copy of this and you go out on your driveway and you point south, you face south, and you have this map so that south is pointing towards the ground, and you look up, you'll be able to see in early January at about 8 p.m. in the evening, this is what you'll see in the night sky. So you'll see these various constellations. The two main stars of the show, though, really the main star of the show is Orion, which is over here in the southeast portion of the sky at around 8 o'clock. This is the constellation that you'll want to be looking for, because once you've found it, you'll be able to find your way around the night sky. Taurus, Canis Major, a couple of other constellations that we'll be interested in as well. But the message I just want to get to you here, this is a free resource and it's very handy. And if you want to see what's going on in the northern part of the sky, what you would want to do is you'd want to turn around, face north, and then turn the map upside down so that north is facing towards the ground. And in here you'll be able to see Polaris, for example, Cassiopeia, which is a very distinct constellation, and so on and so forth. So it's a great way to get started in terms of understanding what's out there and available in the night sky. Other resources that I would recommend for people that are just starting out, H.A. Ray is a children's author. Um, and I remember reading Curious George to my kids when they were small. He also put together a couple of children's books that dealt with astronomy. One called Find the Constellation, and the other called The Stars. Um, Find the Constellations is great. It's kind of confusing at first to understand, what's a constellation? Why is it named the way it is? Why is it shaped the way it is? And H.A. Ray does a really good job of connecting the dots, so to speak, to really simplify the explanation and help people that are new to the hobby understand what they're looking at. Um, Again, he's a children's author, but he writes book. These two books are really appropriate for anybody that's just starting out. So don't let the fact that he's a children's author dissuade you from looking at those two books. As you get deeper into the hobby, excuse me just a second, you'll want to get your hands on a sky atlas that has more depth and detail in terms of the stars that you're looking at. You see pictured here some popular sky atlases. These books are very thorough, and they really allow you to dig down. And when you get into the finer points of star hopping and finding, obscure objects, this is where these atlases, these resources really come into their own, because they've got the detail that you're just going to have in order to recognize whether you're looking at the thing that you think you are. So as you get more involved and advanced, these are a great resource. I've always thrown out the Deep Map 600 as kind of my in-between resource. I love this thing because it folds up into the size of a gas station map, and it's just chock full of information. It has basically the celestial sphere up here is flattened out in a rectangle, and then it's got plenty of major stars, objects, etc. here denoted on the front, and then on the back it's got a plethora of information about each object that's on the front page. Regrettably, this map is no longer in publication, so unless you've got a copy now or able to find one somewhere, regretfully it's not available anymore. I have been doing a little bit of research, and I've come across one that is not too bad as a replacement here. It's a one that's put out by National Geographic, and you'll see listed here 4 different maps. You can buy each of these on their own. I think they run about $10 or so. But if you buy them as a package, they knock it down to like 25 or $30. Um, Not a bad substitute. I'll kind of give you some pros and cons of the northern sky map here. So this is what you'll see with the northern sky map. And what they've done here is they've taken the celestial sphere and they've cut it at the equator and then flattened that thing out and then put it in a map like you see right here. So everything that you're looking at here is above the celestial equator, which is nice, except down here in Houston, we can see many objects that are below the equator. So that's why the deep map was so nice, in that it had that extra territory that we could view. So if you really want to get the full picture, you'd have to get both the northern and southern sky, which isn't all bad. But this is what it looks like. And you can't really see it here, but the constellations are laid out. There are major objects that are denoted here. So I think Pleiades, for example, is shown over here by here's Orion, and then here's Taurus, and then over here's Pleiades. So there are a number of objects that are denoted here, which are cool. And then one nice thing about this that the deep map didn't have is that the constellations have a border around it, so you can get a fuller understanding of where a constellation starts and stops. So that's the front. The back has some really cool seasonal depictions like we saw with sky maps. And I thought this was kind of cool because they actually, I was kind of blow up and look at the winter one. Um, they have on here some sky hopping tips and use of Orion as a signpost already labeled out here. So let me zoom in a little bit more. You can see here, and we're going to talk about this a little bit more in a minute, but they've got how you can use Orion to find other stars and constellations. And then they've also identified some other signposts that I hadn't been aware of or known of. So hopefully I'll be able to incorporate those into future presentations. But anyway, check it out if you think it's great. If you don't like it for some reason, let me know. Again, I'm still continuing the search to find a replacement for that Deep Map 600. Okay, so with that, let's talk about Orion as a signpost. So you may have seen this in past presentations. I have here the celestial sphere laid out as a rectangular map, and what you see here in this green box is really kind of the winter sky that we'll be able to see during what I like to, what I like to call prime time viewing, or during the course of the prime viewing hours during the evening, 7 p.m. to midnight, say. This is the area of the sky that we'll be able to see, and as you can see here, I've got circled in yellow various signposts that we can use throughout the year. So Orion is going to be the one we'll focus on tonight. In the springtime, we'll be looking at the Big Dipper, Arcturus, and Spica. In the summertime, we'll be looking at the Teapot and the Summer Triangle. And then in the autumn, we'll be looking at, again, the Summer Triangle and Cassiopeia. So those are the signposts, but and where that green box lines up, that's kind of our area of interest. So tonight will be our winter sky, and it will be all about Orion. So this is Orion. So I took this snapshot out of Sky Safari. And if you're looking to the southeast at about 9 o'clock Saturday night, because as you know, everybody will be attending the general session tomorrow. Just little astronomy humor there. I mean, I hope you do, but if you do, then Saturday this will kind of line up with what you're going to be looking at. So you go out at 9 o'clock and you look into the southeastern portion of the sky. Here's where you'll see Orion. And it's this object right here. It's just a pattern of stars called a constellation. And you'll be able to make these three stars out very distinctly. This is one of the first things as a newcomer to astronomy I saw in the night sky, with those vivid three bright stars lined up all in a row. So if I can do it, I know you guys can as well. But this is where you'll be looking. You'll see a couple other really bright stars, one down here called Rigel, and another one up here is kind of a reddish star called Betelgeuse. And those are those are the stars that we'll be using to move our way around the night sky. Here's a map of Orion, and here is kind of that border that you see that shows you that it's more than just his belt and these two stars, but there's actually other stars that are part of the Orion Nebula. And then here's kind of the main message, or the main meat of the discussion about how you would use Orion as a signpost. What we're really doing is we're using these really bright stars to get us to other points in the night sky. So starting out here at the belt, if we go from the lower left to the upper right and we follow that out with a straight line, relatively straight line, we're going to come to a bright reddish star called Aldebaran, and that's in Taurus, constellation Taurus. If we follow from Rigel up over to Betelgeuse in the shoulder of Orion, and we follow that out, we're going to find two bright stars called Castor and Pollux, and those are in the constellation of Gemini. If we follow the three belt stars from upper right to lower left, we'll get down to a very bright star called Sirius, and that is in Canis Major, and you can't miss Sirius. I think it is the brightest star in the night sky for for us here in Houston. And then for getting over to Canis Minor, there's another bright star called Procyon where you would go from Bellatrix here through Betelgeuse and follow that out to a bright star there. And so while these will get you to these bright stars, they can also, once you get to a bright star like Aldebaran, and we'll talk about that here in a second, you can then find various open clusters, other objects that are close by. So that's kind of the concept of star hopping and using these constellations as signposts. So with that, we'll dig into the winter sky objects. And as we go through this, I'll be hopefully bringing us back to the concept of Orion as a signpost. So here is Orion, is a nice photograph, and again you can see Betelgeuse and Rigel and the three stars that are in the belt. And we're going to concern ourselves with this region of Orion right now. So while Orion is a great way to get to other parts of the night sky, it also has some wonderful, very accessible objects that are, right there for the taking in the constellation of Orion itself. So this circled area right here is actually shown in this beautiful picture by Rob Torrey right here. So this is kind of a wide angle shot of what you just saw in the previous slide. Here's the Great Orion Nebula, M42. And then over here, you'll see the Horsehead Nebula and the Flame Nebula. And we'll talk a little bit more in detail about those objects here in a second. But again, the point here is that Orion's got some wonderful objects to go look at and view. Here's a nice sketch of Orion, and you can make out the 4 stars of the trapezium down here. Here is a view of Orion that you would see through a small telescope or really even a larger telescope. I've been using this 10-inch Dobbs for various outreach events during the course of 2024. And this is pretty spot on to what we saw through our eyepiece. We didn't see the color, but we certainly did see this fuzzy patch of light. Kind of reminded me when somebody breathes on a mirror in a warm shower or bathroom. You'll see that fog kind of built up. And that's kind of what I thought of when I saw this fuzzy patch of light through the eyepiece of the telescope. You'll see the bright stars of the right here of the trapezium, and that's what you should expect to see through a telescope. If you have a bigger telescope like the Hubble, this is what you'll be able to see, and this is obviously a very ornate, detailed viewing of Orion. And this is a great picture from Don Selly, one of our members here in HAS, of the Orion Nebula. And so with that, I'd like to just kind of go through a few things about the Orion Nebula. Probably one of the most interesting objects out there for several reasons. Number one, the Orion Nebula, you can see this with the naked eye. And so if you go out on a clear night, and I think by this weekend we'll have some clearer skies, you'll go out and you'll be able, if you look for the belt and then you look down below the belt, you'll be able to see that fuzzy patch of light, and you'll be able to see it naked eye. If you have a pair of binoculars, it'll be even more apparent. But it's a really easy object to see, one of the few nebulas that you can see naked eye. And the other amazing facet about the Orion Nebula, it's the closest region of massive star formation to Earth. So this is an active star forming region in our night sky. So a little bit about the nebula. It's about 1,400 light years away from Earth. It is an emission nebula, meaning that the gas around these new stars that are being formed is being ionized, and that glow that we see is from the ionization of the gas and dust, or for the gas around these stars. It's made up. M42 is made up primarily of hydrogen, ionized hydrogen, which is H2, or not H2 like you'd see in the formula for water, but HII, I guess it would be. I need to get my head wrapped around that a little bit better. There are approximately 700 stars in various stages of formation, and these stars are very active, especially in and around the trapezium, there's something called stellar winds that these stars create, and those are emitted particles from the stars. Our own sun generates stellar winds as well, but these are very, very energetic and has a tendency to kind of move and shift the gas around in the cloud. So again, the Orion Nebula is a great one to go after. Not only is it can you see it naked eye, is it accessible, but it also is got some really profound things going on in it. As I mentioned earlier, namely the star formation. All right, so that is the Orion Nebula. Now what we're going to do is find the Horsehead Nebula. And I don't know if you remember it from that earlier picture, but right here next to this one star in the belt of Orion, just below that is a region here called the Horsehead Nebula. And here's another photograph of the Horsehead Nebula. And if you haven't guessed already, this is the Horsehead. And what you're looking at here is not a blank or barren patch of sky, but rather a cloud that is so dense that it's obscuring and absorbing light that is shining behind it. Hence, you get this silhouette, if you will, and in this case, it resembles that of a horse head. So that's what's referred to as a dark nebula. There are also a number of other items in this picture. Just a little bit more about the Horsehead Nebula. It's about 1,600 light years from Earth, and it's a very small object. It's only about 3 light years in size. So in order to see this, you're going to need to have a pretty big scope, pretty dark skies, or you're going to have to utilize something called electronically assisted astronomy, which you may or may not have access to, but I know at some of our outreach events, people have been bringing kit to actually implement that. So that's a little bit about the Horsehead. Again, there's some other cool objects here in this frame as well. So you'll see 5 different reflection nebulas. So you'll see one here, 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 and here. And a reflection nebula is different from an emission nebula in that it's reflecting starlight as opposed to being ionized by it. And that's why you kind of get this bluish hue right here. There's the Flame Nebula, which is an emission nebula right here. It also has some dark creases in it that are dark nebula in nature. And then also up here in the upper part of the picture, you'll see a 5-star gravitationally bound system. These 5 stars right here, 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 and here are actually gravitationally bound to each other and form a quintuple. So you may have heard of double stars, triple star systems. Well, this is a quintuple. So again, I mention all this because again, Orion's got some really wonderful objects in it, and you don't need to navigate really any place. You can just stay right there in the constellation. So now we are going to go out and locate an object that is outside of Orion. And in order to do that, we're going to do the following. We're going to take that line of sight from Bellatrix and Betelgeuse over to Procyon, which is way over here. And then what we're going to do is, once we find Procyon, we're going to kind of split the difference between Betelgeuse and Procyon, and we're going to find this object here, NGC 2244, which is the Morisette Nebula, which is actually in a constellation that fits between Canis Minor and Orion called Monoceros. So here is a picture of the Morisette Nebula. This one is about 6,500 light years away from Earth, so it's way much farther out than the objects that we just talked about in Orion. It is an emission nebula, and it's rather large in size. It's about 130 light years across. This one's going to be relatively difficult to see because it's pretty faint. So again, a large telescope at dark sight conditions is your best bet. Or if you are constrained to the city, using electronically assisted astronomy, you can see this. And I can say that using EAA, I found it with a 2-inch telescope here in my driveway. So it's doable. You just have to have a camera and some other uh, gadgets that are hooked onto your system to use EAA. This is again, it's an emission nebula, and you'll notice here you've got a really bright core of stars right here. And one thing before I forget about it, while you may not be able to see or recognize the cloud that's around here, you probably can find these stars here that form the cluster that's in the middle of this nebula. So, um, something to think about as maybe a consolation prize if you can't get the conditions and the equipment right. But these stars are very energetic, and the stellar winds that I was talking about earlier are actually hollowing out the center of this nebula. So you kind of see like a little bit of a donut shape here, and again, that's being hollowed out by the stellar winds, and that donut area is approximately 30 light years in size, so it's pretty substantial. Again, you can kind of pick up other features here, such as a dark nebula. So these creases right here are really uh, dense portions of gas clouds that are obscuring light, and that's what we have with the Rosette Nebula. So it's a wonderful object, difficult to find, but it is really a cool object to go after. I know the astrophotography group, interest group, they have as their target for January the Rosette Nebula. So there you'll be able to see some really cool pictures of this once the members of that interest group have done their thing. So now we're going to go on to Taurus the Bull. So this is kind of a graphic to kind of show you how this constellation got its nickname Bull. You've got the horns here and here, and then Aldebaran is kind of the bright star that's down here in the lower chest region of the bull, so to speak. We're going to first go take a look at an open cluster called Hades. This baby, open clusters in general, and I'm just, from my own opinion, open clusters are not the easiest objects to find in the night sky because uh, you really have to be knowledgeable about the pattern of stars that you're looking for. But here you have a really good candidate to go after because you've got a really close marker with the star Aldebaran, and you have some patterns in this star formation that are very apparent. So here's what we're going to do. So a little bit about the Hades. It's about 150 light years away. It's about 300 to 400 stars in this open cluster, and the five main members are all red giants. So knowing those colors will aid you in your quest to find these items. Aldebaran itself is not a member because it is a foreground star, but you can use Aldebaran to get very close to the star cluster and begin to find the patterns of stars in the star cluster. So here's some asterisms in Taurus. I'm going to come back to Alley's braid, which is actually over in Pleiades. You've got Davis's dog, the delta wing, and then my favorite of all is the triple double. So in this picture right here, you may not be able to make out the triple double, but it's right there. And what the triple double is, it's just a collection of uh, three pairs of stars, and they form almost symmetrically the sides of a triangle. So you go out with a pair of binoculars on a clear night. You find Aldebaran, again, using our Orion as our signpost. We go from the lower left to the upper right in Orion's belt and follow that over to Aldebaran. Then you can kind of look around in the vicinity, and you will, once you see these stars, you can't miss it. And then once you find them, then you're in Hades. So again, I love this. I love these patterns right here. So that's Hades. Next, what we're going to do is go over to Pleiades, which is one of my all-time favorite objects. So again, we'll use Orion's belt to get us over to Aldebaran. And then from there, we're going to have to kind of look around up in the night sky. And with Pleiades, you have an open star cluster that is visible to the naked eye and is very distinct because it almost has kind of like a bluish color. So look in the night sky around Aldebaran, kind of go from here at about, say, 2 o'clock from Aldebaran up here in the night sky and see if you can find Pleiades. And then when you do, you'll see something like this. So this is the view that you'll see with a pair of binoculars. And again, you will see some of the bluish hue to those stars. And what you've got going on here actually are stars that are reflecting, that are emitting starlight that is being reflected off of a cloud of gas and dust that is out there in the cosmos. So this is what you'll see if you're looking through binoculars. And then here's a photograph that you'll be able to see, and we'll kind of look at that a little bit. So Pleiades is again an open star cluster, and it's these bright stars right in here. This is Alley's braid, which is what we talked about a little bit earlier. And then again, you're seeing here with this bluish tint, a reflection nebula. And these stars are actually moving through that cloud of gas and dust. The gas and dust was not part of its creation, but was rather just coincident to its travel through space. Pleiades is about 430 light years away, about 15 light years in size. And again, it's really a cool object to go find, and it's very accessible again because you can find this object naked eye once you get the hang of it. I like this object for just its aesthetic view. Really, the colors and the swirls remind me of Van Gogh's painting Starry Night, which I'm a big fan of. Big fan of Van Gogh, so it's got another kind of an emotional connection with me. But it's a wonderful object. It's an open cluster that I would start out as make it your first open cluster to go after, and then do Hades, because I think you'll be pleasantly surprised at how easy it is to find this one. So that's Pleiades. Now what we're going to do is move along to a supernova remnant called the Crab Nebula. And I'm going to do something real quick. Let me go back. Yeah. So the Crab Nebula, so here's where we were at looking at Hades and Pleiades. The Crab Nebula is actually up in this neighborhood right here, almost where the moon is shown in this picture. It's right above the top of Orion. So that's kind of its general orientation in Taurus. And again, this is a supernova remnant. So what you have here is a star that was larger than our own sun, and when it ran out of fuel, it collapsed in on itself and formed, in this case, a neutron star. And this neutron star is called the Crab pulsar, and it's spinning at about 30 times a second. And it's emitting a wide spectrum of radiation from that object, from the pulsar. So in this particular case, instead of getting a black hole, you got a neutron star. But what you see here that's really cool is the medium here that you see that is glowing is actually being energized by the shock waves, and no doubt from the pulsar that's spinning inside of this thing, and that's what's giving it this its glow and its ability for us to see it here from Earth. You'll notice that the object almost looks like there's lightning or electricity going on in here. So it doesn't have that flowy, fluffy kind of texture that we saw in Orion, but rather more of an electrical substation, if you will. But that's what you get with a supernova remnant. This is a very small item. It's about 11 light years in size, and it sits about 6,500 light years out in space. So it's a very small, faint object. I have seen it not naked eye, but using a telescope and an eyepiece. And again, here, so if you get to the right size telescope, right conditions, you can see it. EAA, again, you can see it using that tool as well. And that is the Crab Nebula. It's a really beautiful object. Moving along, we're going to go and look at 3 open clusters in the constellation Auriga. I didn't really cover it in terms of how we get there, but it actually resides up above Orion. And what you want to look for here is a bright star called Capella. And then you'll see a series of other bright stars that form this pentagon, if you will. And then once you kind of got your bearings, you can find these 3 star clusters right here. This picture right here shows M37, 36, and 38. If I got those right. Yep. And those are the types of patterns that you're looking for if you want to make sure you're on the right spot in terms of these star clusters. Each of these star clusters is about 4,000 light years away from us. They each contain somewhere between 100 to 500 stars. And again, this is a situation where you're really going to want to look at a resource like a sky atlas that we mentioned earlier to really understand more distinctly what that star pattern looks like, to make sure that you're looking at the right object. We looked at this in our novice lab last February. Now we had a bright moon up, so it was obscuring our view, but I don't think we were ever able to find them just because of the bright moon that was out there. Or at least that's the story I'm going to go with. So these are 3 bright star clusters in Auriga. And then again, using Orion as our signpost, we're going to go over to the constellation of Gemini. So if you remember, we go from Rigel, we draw a line over here to Betelgeuse, and then if we follow that out, we're going to see 2 bright stars over here that are the heads of Gemini, and these 2 bright stars are Pollux and Castor. So once we've found those stars, what we can begin to do is understand the general layout of the constellation. And in order to get to our next object, which is M35, what we have to do is we have to go down kind of to its foot. So here is Pollux and Castor, and we need to follow the star patterns down here to get to M35. I'm doing a Astronomical League binocular program, and I've been trying to get M35 here for the last month or 2. So don't be discouraged if you can't find it. I'm still having trouble myself finding it for sure, but that's where it's located. And here's what it's going to look like. So this object's about 2,800 light years away from us. As far as being an open cluster, it's rather large. And one thing I wanted to point out here, in addition to the star patterns, what you really want to be able to do is pick out the large and different color stars in order to tell if I'm on the right object or not. So in this particular case, you have 4, 5 really large bright red stars that are right here in the center, and then 1 over here to the side. If you can kind of visualize that in your head, and then as you're looking in the night sky, look for that kind of pattern in those colors. That's one tip that I can give you to try to help you navigate yourself to that cluster. So that was M35. Now we're going to go to a planetary nebula, which is called NGC 2392. And in order to get there, so we'd have to go back up to Pollux and Castor. To do M35, we came down this side of Gemini and came up by the foot. Here we'll want to go down the other side of Gemini and kind of stop at the waist and look around here. And when we do, this is what we'll see. So this is affectionately referred to as the Eskimo Nebula. It's a planetary nebula, and for those that aren't familiar with a planetary nebula, this is when a star the size of our own sun, when it runs out of fuel and collapses, rather than going and becoming a neutron star or a black hole, it becomes what they call a white dwarf. So it's not as uh, dramatic when it runs out of it, when it runs to the end of its life, but it can create a wonderful object. And this planetary nebula is what you're seeing here. So the gas and dust that was shed off from that star, the original star, kind of was puffed out and blown out, and then the radiation from that bright hot ember that's still left there is radiating this area here. And this is what Hubble shows us. And then here's what you would expect to see in a telescope. You would see really no more than a smudge of light, but it would be very distinct. And so that's the Eskimo Nebula. Again, a very small object. It's less than a light year in size. So you're going to need some um, relatively large equipment in order to find this thing. Um, and again, EAA would be an option as well. Now what we're going to do is move on over to Canis Major. And if you remember, we'll get over to Canis Major by following the other side of Orion's belt. And we'll follow that down here to Sirius, which is the brightest star that you'll see in the sky. And then once we're down here, we can make out the pattern that makes out the constellation of Canis Major. And if we're able to do that, then we can find these two objects that we're looking for. So here's Sirius, and here's where we would find M41. So Sirius is kind of the dog collar, if you would. And then down here in kind of the upper part of the dog, you'd see M41. And then back over here near the base of the tail is the other object that we'll be looking for. So here's M41. This baby's about 2,300 light years away. It's got a big, beautiful orange star at the heart that is very luminous, about 700 times more luminous than our own sun. There are about 100 stars in this nebula. And again, the tip that I would give you is to look for the large, bright, different colored stars to help you understand if you are in fact looking at M41. But that is M41, and again, you'd find Sirius and then kind of go down towards the chest of the dog, so to speak. NGC 2362, which was back here kind of at the base of the tail of the dog, that's our next star cluster. And this star cluster has many gas giants in it, relatively young in age. So this cluster is a great tool for astronomers and astrophysicists to use to better understand the formation of gas giant stars. And that's what we're looking at here. Moving along, we're going to go to Perseus. So this is another constellation. We didn't talk really about finding this one. This is more in the northern part of your sky. So if you turn and face to the north and find Cassiopeia, which is this distinct W or M-shaped looking constellation, you can find Perseus, which is kind of at 2 o'clock from Cassiopeia. And then if we can do that, we can find a couple of neat things in here. There is a triple star system called Algol, and there are two stars that eclipse each other from our line of sight. And the magnitude of the stars will drop as one eclipses the other. So that is really an interesting phenomena to go out and witness. Here is kind of an animation that shows you what's going on. And you'll notice as the one star goes in front of and eclipses the other star, the brightness tends to dim. And then that's how you know you're getting this eclipsing motion. So that's Algol. This would be a really good challenge for anybody that wants to go out there and try to do that. But I've tried and have not been successful to date, but I will not stop trying. The last object that we're going to look at in our hit parade of objects for the winter is the California Nebula. So again, it's in Perseus, and it's up here right in this nature, in this neck of the woods. If you go out over this away, you'll see Pleiades, and you can kind of see these kind of running in parallel as the night sky goes by. And here's a nice picture of the California Nebula. Again, another emission nebula. And the cool thing about this one, there is a star over here called X Persei, and it is actually a runaway star, meaning that it is moving at a high velocity relative to its surroundings. So something must have happened to launch it out into a different direction than what the rest of the neighborhood is doing, so to speak. It's a very large star. It's about 30 times the size of our own sun, and it's a very distinct star. So if you can find that star, you have a shot at getting seeing the California Nebula, although it is a relatively dim object. So again, EAA, I know, is the way that I've found it. There may be some other techniques out there as well. Also remember that Jupiter is still in the night sky. And again, as I mentioned earlier, Mars is also coming into view. So as you look into the southeast in the early part of the evening, you'll see a very reddish, bright, looks like a star, but it's actually the planet Mars. And it is coming up into opposition here this month. So here is just kind of a recap of all the objects that we've talked about here tonight. I have here on the far right column, my suggestions in terms of the type of equipment or technique that you would need in order to find these. But again, talk to others. There are more experienced, knowledgeable astronomers than I in our club. So, but this would just at least get you a starting point that you can take and go out and use as you stargaze through the winter sky. A few other celestial events coming up. There is a meteor shower that's going to hit its peak tomorrow. The quadrantids. On the 7th, the moon will be in perigee. On the 11th, Venus will be at dichotomy. In other words, it's going to appear half illuminated, kind of like a half moon. On the 15th, Mars will be at opposition. So Mars will be at its closest position to Earth, and will be available for some really prime viewing and photography. And then on the 20th, we have lunar apogee, where the moon is farthest from the Earth. So just kind of a smattering of other upcoming events. Get out there and stargaze. Wintertime is a wonderful time of year, and you've got some really wonderful objects that you can certainly get your arms around, and please do that. It's great. And I also want to remind everybody that tomorrow night we have our general topic, Explore the Moon, and our speaker will be Robert Reeves. So with that, I will stop sharing my screen, and I'll see if we've got anything in the chat. And let's see if there's anything there. Will this presentation be available to see again since it is being recorded? Yes, it will. What happens after tonight is the recording. I'll send that over to Joe Califf. He'll do some editing and then post it on our YouTube channel. So it will be there, and you'll be able to view it again. Holly Browning asks, when you say large telescope, what size do you mean? Well, that's a good question. I think I've got it on my little chart, although I've stopped screen sharing. Typically, when I'm talking about a large telescope, I'm talking about something that is greater than or equal to 6 inches. I think in general, I think that when I talk to people, they say like 10 inches or larger would be considered a large telescope. But I'd say 6 inches would be a good starting spot there. So that's what I'm talking about there, Holly. And it sounds like I answered your question, which is always a good thing. Let's see. I think those are all the questions in the chat. Did anybody have any questions that they just thought of? And you can come off mute and ask your question if you'd like.
Yeah, I have a question, which has to do with the size of the telescope. And I was looking the other night at I mean, all I've been using so far is binoculars, and
Right.
the most obscure object I've found so far is the beehive cluster,
Okay.
which is fun. Um, but what I'm thinking about is getting there's a Celestron telescope that is I think it's a reflector, and it's about 5 inches, and it's got some kind of a mechanism that you can use with your phone, so that although it's not it won't slew for you and find your object. It will guide you so that you can manually move the telescope, but the map apparently on the thing is showing you where to go, how to get to it. And I was
Yes,
wondering if you've seen that. Does it really work?
I have.
Is it
Yes,
functional?
that was my granddaughter's fifth birthday gift, was that Celestron. And luckily her dad, who's my son, is a technical genius because he got it to run. So I have seen it in operation at a outreach at the George Observatory, and yes, it does in fact allow you to say, if you wanted to look at let's just say pick an easy one, the Pleiades. You would tell it, hey, I want to go see the Pleiades, and it would put a target, if you will, on your screen, and then it would give you, I think, if our memory serves me right, there's some arrows that kind of, as you move the scope, tells you if you're getting closer or farther away from that target area. And then when you land on it, it'll kind of light up green or something to that nature, and then you look through the telescope and you can then determine, yeah, I'm on the Pleiades, it worked. So that is a technique to use. It does work. You do have a little bit of setup and calibration that you've got to do, before the sun goes down, but it can work. So yes, that is an alternative. I think in the case of Pleiades, I mean, personally, what I teach and what I preach is to go out and see if you can do it on your own. Star hop on your own, look for these objects on your own, and at least take some time to learn how to navigate the night sky and find these objects. If you get to a point where it's just not panning out and it's becoming more frustrating, and you're looking for a telescope anyway, yeah, by all means, that is a good opportunity. I bought it for my granddaughter because my son and her are just learning, and they live up in Kansas City, so I don't have any chance to go out there and work with them one-on-one. So that's what they're doing. But it's a great tool. Yeah.
Yeah. Well, I've done some of the star hopping, and I've gotten around. In fact, I was wondering about those three, M35, 36, 37, I think that you showed us.
Yes.
And are those easily seen in binoculars? I've got 2570 binoculars.
I can't say for sure, because when we looked at those last year, and I haven't really made an attempt to look at them since, I wasn't able to find them. And again, it was because we had a pretty bright moon that was up in the night sky that night. I think, Matt, are you still on the line by any chance? Or did he drop off? It looks like he dropped off. Matt was out there with us that same night, and I know he had a telescope that was out there looking. I gotta believe that those three would be good candidates to find with binoculars, because if you've got that wide field of view, what I would try to do is get the three clusters in a wide enough field of view that I could see them in that row or in that arc that I showed on that one picture. And then once you've kind of got them sized up that way, then you can zero in maybe with a more powerful device and a more powerful telescope and look at each cluster individually. But that's kind of the approach that I would take if that when I was doing it. when I try it again anyway. So
Okay, great. Well, Jim just had a message saying that he's found them with binoculars.
yeah.
And Jim, do you know what the power of your binoculars is?
Jim, are
7
you
by 50. So I should be able to see it because mine are 25 by 70.
okay? Excellent. We had, let's see, there was one other question. Let me scroll back up from Brenda. Is the public able to use the telescopes at George for photography and data? A bit off topic, but yeah, let me talk about that. You can, the only way you can really use any of the, if it's not your own telescope, if you're going to go out and, the way the George operates is they have a number of telescopes that are out on the observation deck that people bring and will line up objects for the public to go view. Really, the only way you can get a picture is by holding your phone up to the eyepiece and taking a picture that way. In order to use anything more than that, like a astrophotography camera, along with tracking and guiding, what you have to be is a volunteer out there that has been qualified on the equipment and has been able to punch their ticket, so to speak, to be able to come out on an off night and do photography. So I know I'm qualified on the East Dome out there, which is run by the Fort Bend Astronomy Club. So I can do that, but I've never done that yet. I just haven't had I live in Kingwood, and Brazos Bend State Park is a hour and a half, 2-hour drive. So I haven't done that, but that is a way that you can do that, is to become a volunteer and become qualified on the equipment. Did that answer your question, Brenda? Is Brenda still with us? Yeah, she's still there. Okay. Let's see what else we got. Oh, okay. Great. Okay. Again, any other questions before we sign off for tonight? We went a little bit long, but hopefully it was worthwhile.
Good job, Chris. Very good. Good job, Chris. Well done.
I appreciate it, Bill. Thank you very much. And my big payoff will be y'all get out there and look and come back with stories of, hey, I found this, I found that. That'd be even cooler. Okay. Unless I hear any other comments or questions, I'm going to go once, go twice. And with that, I'm going to end the meeting. So I'd like to thank you all for attending tonight. And I wish you all a pleasant new year and a warm next week.